So today we're going to be reviewing the exponent properties. If you remember, there were about 7 exponent properties that we went over right around Christmas break. And they dealt with what happens if we're multiplying and we have exponents, dividing with exponents, negative exponents, all of those sort of things. So I'm going to go through the first probably 3 problems with you and kind of reintroduce everything. And then I'm going to ask you to try the other 11 problems on your own, and then we'll come back together and I'll go over all the answers for those. After you've watched the video and you've completed the worksheet, if you have questions on any of them, if you're not sure why I got the answer that I got or anything like that, feel free to come over during Flex and ask questions. So, for the first one. My exponents aren't showing up real well, but it should be 6 to the third times 6 squared. You're going to keep the base the same, which is our 6, and we're going to add the exponents. We're going to do 3 plus 2, and that's going to give me 6 to the 5th power. For number 2, you'll notice that we have 2 bases. We have the negative 3, and we have the 4 squared times 4 to the third. We can only put exponents with the same bases together. So we can't do anything at all with that negative 3. It just has to come over in the final answer. The 4's, on the other hand, we can add them together and get 4 to the 5th. So the final answer is negative 3 times 4 to the 5th. Problem 3, 5 to the 8th times 5 to the 9th. Again, we're multiplying, so we're going to add and get 5 to the 17th. We are just simplifying. Okay? We're not evaluating. Evaluating is when I would actually ask you, what is 5 to the 17th? Here we're just simplifying or making the problem smaller. Remember, if you see a fraction sign, if you see, let me make one up real quick, 3 to the 4th over 3 squared, you're going to subtract them and get 3 squared. Remember that if you see 4 to the 6th times 2 to the negative 2nd, that negative is going to bump to the bottom of the fraction, but the 4 to the 6th would stay on the top. At this time, I'm going to ask your teacher to pause the video. You're going to try the other 11 problems, and then they will turn the video back on and we'll go over the answers. So now that you've had a chance to look over the other 11, we're going to go down through those and go over the answers. So in 4, we're going to combine the 6's, and we're going to get negative 6 cubed times 9 to the 5th power. It does not matter if you have 9 to the 5th or the negative 6 cubed first. As long as both pieces are there, you're fine. For 5, we have bases of 5, 3, and 4. The 5 doesn't have anything to combine with it. The 3 is going to change to the 8th power, and the 4 will become 4 squared. The 4 actually didn't have anything to go with it either, so it just carries down along. So now we're going to look at problem 6. Again, we're looking to combine our exponents. Negative 10 has no matches. 7 to the 6th power. 4 plus 2, 7 to the 6th. I have 2 1's in the first parenthesis, 1 1 in the second, so that's 1 to the 3rd power. My 3 doesn't seem to want to write. There we go. And the 3 doesn't have any matches, so it just comes down along. 7's the first time we see that fraction bar where we're going to be subtracting. So 3 to the 6 minus 3, that's 3 to the 3rd power. 8, look at 8 as 2 pieces. Do the 2 separately from the 8. 7 minus 6 is 2 to the 1st power. 8 to the 2 minus 8 is also 8 to the 1st power. Same thing on 9. Look at that as 2 separate pieces. 3 to the 1st times 9 to the 3rd power. For 10, you're going to see that we have 3 pieces now, the 9's, the 5's, and the 4's. When I go to simplify, watch your subtraction. I'm going to get 9 to the negative 6th times 5 to the 6th power times 4 to the 3rd power. Negative exponents need to move to the opposite side of the fraction. The 5 to the 6th and the 4 to the 3rd were not negative, so they stay in the numerator. Only the 9 to the 6th bumps. 11, we have 3 pieces again, giving me 6 squared times 7 to the 4th times 2, or 2 to the 1st power. 12, you should see 3 pieces. The negative 6 has a positive exponent. It's going to stay in the numerator. The negative 2 to the 6th is a positive exponent. It will stay in the numerator. The 5 to the negative 4th has to bump down to the denominator in order to get rid of that negative exponent. Last 3, working with subtraction still. Remember, we're subtracting a negative. So this is actually 3 to the 4th minus a negative 2 power. That's going to go plus positive and give us 3 to the 6th. 14, I have 2 pieces. I'm going to subtract. I get 4 squared times 9 to the 7th. Because again, that's 5 minus that negative 2. So it's going to give me 9 to the 7th. Last one, I have 3 pieces. The 5 squared is positive. It's going to stay in the numerator of the fraction. The negative 3 to the negative 2nd is going to bump to the denominator to become happy. And the 6 to the negative 1st power will also bump to the denominator to be happy. Again, if you have any questions on this, if you're not sure where I got any of my answers, anything like that, please stop by during Flex and I'll be more than happy to help you.